Hello and welcome to this Let's Talk Data podcast brought to you by Proact and NetApp. I'm your host, Tony Gent, and in today's episode, we'll delve deep into the landscape of containerisation, guided by our expert, Jonas Larson, seasoned professional in the field of DevOps. But what exactly are containers? How do they differ from VMs and servers? Is there a difference between Kubernetes and Docker? Join us as we navigate through this terminology and these concepts from their not-so-distant origins to today's practical applications. Stay tuned for an enlightening conversation that promises to expand your understanding of this clever technology and how it truly does revolutionise software development.
I should have kept my Commodore 64 t-shirt on for this one.
Okay, yes, possibly. Rather than the Justin Bieber one.
Yeah.
Oh my God!
Are containers similar to mainframe architecture in that respect? Because actually mainframe was designed as that, wasn't it? It was a computer system that allowed you to run individual elements independently.
In the mainframe and in the top-end Unix, you can even swap CPUs and memory live while the system is up and running.
Whoa.
Anybody that has been around Unix systems and mainframe thinks that the Linux revolution is kind of, wow, this is...
How do you navigate that? If you're starting with this, how do you navigate finding which pieces fit you? And how do you pick? I mean, there are so many choices.
Right, in this podcast, we will be discussing containerization. And I think to a certain extent, from an IT perspective, containers have been around for a long time now, but there's still quite a lot of common misconceptions about the way that containers are used and what benefits they have for the business. And there's a lot of names running around in the container space that people find almost confusing or at least interchangeable. So we're going to try and clear up some of those myths today. To help, we have an expert. So I'll introduce Jonas Larson. Jonas is one of our Kubernetes and container specialists within Proact, and he's head of our DevOps. So, Jonas.
Yeah, so I was born 74, so I guess since 75 or something.
So you're younger than me then?
Yes. Aren't we all, I was going to say. But,
thank you. Yeah, it's the hair. Yeah.
No, I mean, containers has been around for a while. I started my IT life in the Unix sphere and worked with Unix and pretty much only Unix in the beginning at ABB. And from there, Linux kind of came into play and Unix was kind of downplayed over the years just because Linux beat Unix basically to its own game. Mm-hmm. And with Linux and, all of the web happening, I jumped on that bandwagon and did a lot of programming and web stuff, mostly on the back-end side. And with that, obviously, came containers. And Docker came around, and I definitely jumped on that, with a better release even on Docker, and, has been on that bandwagon since then. So 2015, doing containers every day, all day. I think it's great. But at heart, I'm still a Unix guy.
I was going to say, so when you did Unix, did you do mainframes?
Not mainframes. So I'm on the HPUX team. Yeah. And I've done all of them, of course. But I still consider me as an HPUX person. I don't know why. Whatever you started with kind of sticks, and that's what defines you, whether you want to or not.
I'm still a netware guy, so you need grey hair to be able to remember that lot. So
I should have kept my Commodore 64 t-shirt on for this one.
Okay, yes, possibly rather than the Justin Bieber one. I was going to say when you think about it, are containers similar to mainframe architecture in that respect? Because actually, mainframe was designed as that, wasn't it? It was a computer system that allowed you to run individual elements independently.
Yeah, I think there's a lot of common design choices in there, but on a totally different level, of course. So the mainframe and even the Unixes, they compartmentalize a lot of the stuff. So in the mainframe and in the top-end Unix, you can even swap CPUs and memory live while the system is up and running. So anybody that has been around Unix systems and mainframe thinks that the Linux revolution is kind of, well, this is crap. We're going backwards like 25 years, but it's good enough, and I guess that's good enough and cost effective, and that always beats perfect, so or better.
Yeah, agreed.
Okay, so what we're saying now is mainframes, virtualization, and containers are the same thing.
Very simplified, yes. And then we can speak about yeah, exactly. How long has containers been around? Well, since the 70s, basically. And so if you're a Unix guy, and you probably heard about chroot or change root, so that's basically the first real containerization that we had, that was actually adopted by a lot of operating systems. So in Unix, chroot was the first thing that we used that was a container. And from there on, we have been, iterating through a lot of different containers over the years. So
yeah.
That's the same as doing virtual environments in Python, right?
I mean, that would be a really, really good analogy, because that's exactly, so we often get the question, but isn't VMware a container as well? And no, it isn't. Not in the technical sense, because a container is virtualizing a complete computer, including the CPU and everything. So a VMware VM, for example, or any VM really, has its own kernel, its own underlying hardware. Obviously, it's virtualized, but so you can run different types of hardware in a virtualization system. But in a container, you never do that. You always run on the kernel. So you only have the one kernel in the operating system that is running, and you're just doing the user space stuff that is being containerized. So it's much more lightweight. So it's like a Python VM. So in Python VM, you have a separate Python environment, but you're still using a base Python executor or a binary, and you build on top of that. So it's very similar.
Okay, cool. Wow. Okay, low level for starters. Okay, so the key thing here, I suppose, and let's talk about terminology a little bit, because there's a lot of terminology going around with regard to the way that containers work. So what's a container, and what's Kubernetes by comparison to a container? Because certainly from my perspective around the industry, I feel those two are interchanged a lot.
Yeah. Yes. So Kubernetes and others like Docker Swarm, they are orchestrators. So basically, they help place workloads on servers. So, for example, if I want to run, let's say, 3 replicas of my container, so the same container 3 times, I don't want to place all of them on the same node, on the same physical node. Let's speak physical nodes, because it's easier to understand. Otherwise, we'll have multiple layers of virtualization. So I have 3 physical nodes. I obviously want to put each container on one node, one distinct node, because if one node fails, I still have 2 containers running. I don't want to put all of them on the same physical node. So that's what orchestration does, very simplified. So basically make sure that we follow the rules on placing stuff, and we define a state. So I want to have these 3 things running, I want to have the other thing running, and I want them to be exposed through this service to the internet and so on. So that's what Kubernetes does. It reads or takes the state that you want to achieve and tries to achieve it. So it's
Understood.
the orchestrator.
So it's you define a policy for the level of redundancy and the level of availability for your application, and then
Exactly.
you let Kubernetes take over and look after that for you.
Yeah, so you tell it the plan, and it will execute it. It will try to execute it, I should say. So it will then tell you what it could do and could not do. Pretty much same as... Sorry.
So Docker is a competitor, essentially, for Kubernetes. They're 2 products that do similar things.
Yes. So Docker Swarm is the competitor to Kubernetes. Yes. So Docker Swarm is also an orchestrator and also does these things that we said. It's a little bit less complex, but in essence, it's kind of doing the same thing.
Okay. So what are they called? Containers? What's the product that is running the container, or is that a separate? Is there a separate product out there? Is there a separate engine that we use?
Yeah. So if we were confused before, now we're going to get really confused.
Okay, good.
So I mean, Docker is the initial, let's say, container king. So they created Docker, which is a lot of things. So Docker is the tool that you run on your computer when you want to build an image. It's also the thing that runs the image itself. So it's also a container engine. And then it also is Docker Swarm. So it's a lot of things, basically. But Kubernetes, as a comparison, is only the orchestrator. You can't build an image with Kubernetes. So, and that's kind of where Docker started out. So they did everything, and it was only Docker and Docker Swarm. And then Kubernetes came around, and they said, well, we think Docker is a little bit too big, maybe. It's doing too much. It's not, sticking to the Unix philosophy of doing one thing and one thing well. So Kubernetes came around, says, we're only going to do the orchestration part. We don't care about other things. Other tools can do the other things.
So Kubernetes is essentially running containers on top of a Docker engine.
Yeah, so Kubernetes doesn't even run anything. It's only instructing a runtime, a container runtime to do things. So Kubernetes is basically the captain saying, okay, do that, stop that thing, start that thing, and so on. Yep. And it doesn't even do it. So it only instructs the container engine, which could be Docker. So Docker is a valid container engine. Nowadays, we have moved away from Docker because it's a little bit too big, doing too many things. And Docker have slimmed down something called containerd, which is basically Docker, but removed all of the extra stuff. So it's basically only the runtime. So you could run Kubernetes and containerd, and Kubernetes then instructs containerd to start this image, or stop that, do this, do the other things, and it's all run in Linux normally. Yep. It could be run in Windows as well, but it's not that common and not that spread yet. So
yeah, I think to a certain extent, Linux tends to be a lot lighter weight, doesn't it? So I suppose Windows, you've got all the other things that go along with Windows sitting in there to take up more space. So Linux is a little bit lighter normally.
I think it's mostly actually licensing issues. So obviously, Linux is open source, and anybody can take it and build upon it. And that's kind of where these companies are coming from. And also there's a lot of Linux heavy companies that have invested in Kubernetes, like IBM, Red Hat, also Microsoft, of course, because they are Linux heavy these days. Who knew, right? So, but it's more of a Docker was its own company, still is. Actually, I think Mirantis bought them anyhow. But Kubernetes is not governed by a single company. So it's governed by CNCF, or Cloud Native Compute Foundation, which is a foundation. So why would you want to have a foundation doing stuff? Well, because it takes away the possibility for a single company to go rogue and just say, I'm going to conquer the world, and let's just raise the prices by...
I'm tempted at this point. I don't know about you, Christian.
I'm kind of biting my tongue here a bit, but yeah, that sounds like it would be a bad idea.
Yeah, I mean, who would do that?
So yeah,
who would do that?
Who would do that?
But, who would?
No,
I mean,
right.
It never happens.
So, but Kubernetes came from, if I've understood this correctly, it was basically developed inside of Google, right? As a start, this started inside of Google as a project.
Yeah, exactly. So there was a project called Borg. I don't know if it has any.
It's got to. It's got to.
They player Borg.
They made no. It's got something to do with Star Trek, hasn't it? They made that acronym fit. Would be my guess.
Maybe. So it started at Google as their way of managing containers, and then Google decided that, this is something that we want to have others work on as well. And they donated it to the Linux Foundation. And the Linux Foundation created Cloud Native Compute Foundation as a sister foundation in order to manage Kubernetes and a lot of other stuff as well.
Nice. Okay, cool. So, so obviously, one thing we haven't really touched upon is how you develop for containers, because I'm assuming that we're quite, or most businesses are quite used to monolithic applications, whereby you have a server, it does a job, and that so you've got a SQL server, it does SQL. You've got an email server, it does email. You've got a web server, it presents web-based pages. So you've got a file server, it does files. But the whole idea of containerization is very different to that. Are we into this premise of the fact this term microservices, whereby everything is separated into individual chunks to make it far more versatile, or is it something slightly different with containers?
Yes. So there's a lot in that question. I'll see if I can. No worries.
15 things.
So let's start with microservices. And so Kubernetes in itself is a microservice design style guide, if you want. So if you wanted to study how to do microservices, you can definitely study Kubernetes itself. And the way Kubernetes works, you will get the most benefit out of Kubernetes if you run a microservice payload on top of Kubernetes, because then you get all of the functions that Kubernetes can do. But you're not restricted to doing that. So a container is a process executed in a Linux box. So anything that you can execute in a Linux box, normally you can run in Kubernetes as well. So and we see a lot of example of that in the beginning. We speak about this like it was 60 years ago, but it was 2015.
Exactly. In the beginning, 9 years ago.
In the beginning, yes, exactly. A long, long time ago when I had hair. No, not that long ago.
When mine wasn't grey.
Exactly. No, we had there were a lot of discussion on, what should you run on Kubernetes and why should you run, this, that, and the other on Kubernetes, and can we run databases, relational databases on Kubernetes and so on. And the short answer is yes, we can run anything on Kubernetes. And the longer answer is, but should we? So Kubernetes is a tool. It's very, very good at certain things, but it's not the best for all things. And I think this is a lesson I think we have learned and probably will relearn over and over and over again. We're not going to get one single shiny thing that is going to fix all of our problems and will be the go-to end-all problem solver. So, but saying that, microservices is the concept of we spoke about the older way of doing application development, like a 3-layer or 4-layer application. So you have your kind of presentation layer, you have your middleware of some sort, and you have a database. That is still very common and very, very used. Most applications today are built that way, I would say. And it's still a very, very good pattern for a lot of things. So we shouldn't dismiss that. But microservice, on the other hand, would be, let's say you have your old application, three-layer application, and you'd have let's say 40 main functions in that thing. So you have, add account, remove account, I don't know, whatever, stuff. So in a microservices world, you would basically take those 40 functions and break it out. So each function would be its own microservice. The benefit of that, at least on a theoretical plane, is that of those 40 functions, not all of them are fast movers, right? So there's only a couple of things that you actually work with. So you probably have 3 or 4 fast movers, and the other 30, whatever it became, 37, are not changed a lot. So imagine the code base that you have to change. If you have to change, then this is a real world problem. So we have to change something in a 3-layer application with just one code base. Yeah, it becomes complex, and you have to change something, and then you have inadvertently created something else somewhere that you didn't know about, and you have issues and bugs and stuff going on. So that's kind of the problem that we're trying to solve with microservices. So instead of doing a big chunk of things that we have to change, we have smaller chunks that we have to change. Yeah,
the analogy I've always used is Spotify, which you may be more familiar with than I am. But the premise being that the way that Spotify's interface is set up, rather than having an interface that everything is just in one interface, they microservice the individual elements. So, for example, what is delivered for you today as your own little portal is customized for you, but that is a service in its own right. The search button is a service in its own right. So if more people run a search, more containers are loaded to allow for more searches to be run, so that then goes off and does its own thing. So essentially, we're load balancing not the application, but every single individual component of the application, so we can cope with scale much better.
Yeah, assuming that you adopt the microservices way of working, that is using HTTP as carrier for traffic and so on. So and that's another thing that maybe we should get into a little bit. Why use HTTP? Because it's a crap protocol compared to other things. It's slow, it's chatty, there's a lot of data you have to send and so on. But it's really good at a couple of things. So it's very easy to load balance, and you can manipulate headers. So those two things kind of make it superior to like using TCP sockets or something. TCP sockets is thousands of times faster than using HTTP, but it's still not good for this use case.
Really? Okay, interesting. I must admit, I never think of it at that level. I never think of stuff whether it comes, but I do think I am surprised from a technical perspective as to why we use HTTP and XML generally for these things, but they are massively verbose. You have to write everything essentially in text and send these enormous strings through, and I always find that quite obscure with regard to very inefficient in my head.
Yeah, yes, and obviously when you write code, you use tools so you don't really see all of that. So when you see the code, when you inspect the code, on the network, then it looks very difficult to read and so on. But obviously that's not the way you write it and view it. So that would be close to terrorism.
So but that's also, that kind of fits with the microservices part also, right? So you take out the presentation layer HTTP back to the client in its own thing. So you can, as you mentioned, Tony, you can scale that individually based on traffic instead of having to scale other components that doesn't have the same load. So you, in totality, you can then possibly or probably get better CPU utilization out of your CPUs on what matters, as opposed to the whole thing where it's all intermingled. And that also, doing HTTP that way, and since it's fairly easily manipulative, or you can manipulate it easily, you can then redirect traffic to where you have resources available.
Yeah, exactly. And definitely you can use also the protocol to do, let's say you have a new feature and you want to have some users get exposed to that feature. So you can have, let's have everybody that has this, let's say, special header set, they get a new feature. And let's say we have a loyalty program or whatever, something that, so you get a new feature and then we can observe the behavior and do we get errors and how we're doing. So HTTP is superior for that part as well. And obviously everything is on the web these days, right? So when we write new applications, we're not writing we're not writing fat clients anymore. There's very, very few use cases that we need to do that for these days.
Yeah, and it makes it easier for development as well, because you do everything on the back end. You don't have to distribute a new client. You don't have to distribute new software to your users. That's kind of the browser companies does that for you. So you don't basically outsource that to Chrome or to Google and to Microsoft and whatever, Safari and Apple. They handle the client part. We handle our own business logic and our own presentation layer.
Yeah,
that makes sense.
Yeah, definitely. And what Tony said before about having different parts of an application going to its own separate URL, and that's exactly what we do, because the web browser can utilize channels. So you can have, the more different URLs you have for one, let's say, web page, you see it, you observe it as a web page when you, as a user, look at it, but it can be, let's say 20 different URLs that is being visited, or it is, obviously, and everybody that has observed a web page being loaded, you can see there's a lot of stuff going on in the backend. So, but then it can load things in parallel instead of loading it in sequence, which is obviously a lot better for the user experience. And each microservice in Kubernetes is also individually load balanced, like you said, automatically. That's one of the things you get with Kubernetes. So,
and this is all leading down towards, and I'm assuming this is the reason it was designed this way. So essentially, we're talking about if we can take the service that we're intending to deliver to our customer, build it into tiny little components that we can then scale depending upon load, interlink all those components together with some sort of orchestration platform, Kubernetes in this case, then this is the perfect position to do cloud deployment, because cloud works extremely well where you have very efficient delivery of workloads. Maybe less so when you're just trying to transfer your entire environment into the cloud. But if you redesign your workloads to work with this sort of containerized microservice approach, you end up with a much more cost-effective way of delivering that service to your customers.
Yes. So you gain a lot of things, and not only from let's say the business part of it, but from the developer part of it, which I'm more interested in. Obviously, we have to make money as well. But again, coming back to the 37 functions that are not really moving, and only 3 that are moving, well, you spend a lot of less time fixing stuff because you have to fix a big chunk of thing instead of just fixing the small things. And then you can have a lot faster pace on, introducing new stuff, introducing new features that the commercial side wants, and so on. So there's a huge developer benefit on doing microservices as well. So
is this just for developers? At the end of the day, I suppose many businesses out there might be thinking, should I be looking at containers for my workloads? Should they only be looking in this direction if they have a development team? Is this where this approach is beneficial?
Yes, of course they should.
Yes, because they should have containers, or yes, they should buy some developers.
Yeah, just ditch everything else and go
that's
all
fine.
in.
Yeah, that's fine. Yeah, all your money in one basket. That's the way forward.
Exactly. No, but so shouldn't really talk about containers that much because that's not really the target. So the target is Kubernetes. And that's kind of important because if you say containers, then there's plenty of different container runtimes that could be the target. And that's not that uniquely beneficial. But if you say Kubernetes is the target, then suddenly you get something very, very interesting. You get a single target approach. So if you want to, get some new developers, and so how do you describe, what the target is for them? Well, in the old days, we had to say that, well, we're running RHEL 6, with, Java this version and JBoss that version, and you have to use these libraries and so on and so forth. And then you have to live in that ecosystem. Well, the new ecosystem is Kubernetes. And then we can get much more freedom to developers. You wouldn't hire your handyman and give him your tools and say, you have to use my tools. Otherwise, you can't work here.
Give a carpenter a plumber's tools. Is that what you're thinking? That's good. That's going to work.
Yeah, I think it's very, very beneficial. It's a lot easier to hire people, developers. Developers themselves has a lot easier job of actually acquiring the knowledge that they have to have. So, and for once, the industry kind of seems to have agreed that Kubernetes is the way to go, which is very unique.
So we're saying that because individual elements are within individual containers, you can use entirely different programming languages to be able to run them, to design them if you want to. You just have to make sure that the interface that comes out is common so that they can communicate together.
Exactly, and that guarantee you get from Kubernetes. So there's a lot of stuff that is removed from the developer responsibility when you use Kubernetes, as opposed to, let's say, Docker.
Yeah, there are two sides to this, I think. The one thing is Kubernetes, when it's up and running, is basically providing an API to the developers that they can utilize, right? So they connect to Kubernetes. They don't care about the underlying infrastructure at all, because all they're seeing is the API they've been given access to. The developers are then being limited by however the resources are allocated within that Kubernetes cluster or setup, right? So in a way, you give the developers the API and say, okay, go do your thing, without them having any insight into what's actually happening on the back end. So you need to have someone on the back end that understands how this works to be able to provide the resources they need, the storage space they need, the storage speed they need, the services, load balancing, all of those networking things. The physical part of this needs to be there as well. I mean, Kubernetes doesn't remove the requirement for actual hardware to run stuff on.
What?
The same way virtualization doesn't do that, right? You're limited by your actual resources. The problem, as I see it, is how do you bridge that gap between those two, right? Because you as a developer, you don't really care what storage is on the back end as long as you get what you need.
So we're saying that. So we're introducing another layer, but we're introducing another layer that requires some degree of management and some degree of organization and some degree of knowledge. So we've got your developers who just develop. You've got your infrastructure guys who just buy infrastructure, and then you need someone in the middle who understands how Kubernetes works.
How do you bridge that gap between the traditional kind of infrastructure on-premises people and the developers that don't speak the same language at all?
I think the answer might be employ Jonas. To be honest, I think that's probably the answer. To be honest, in this situation,
that's one way.
That's a clever guy as a service is always good.
Yeah. So the interesting part of this is that CNCF, Cloud Native Compute Foundation, and Linux Foundation, they are obviously, this is a complete ecosystem. So there is training and you can take the official training. The good part about this is that it is a standardized product these days. So if you learn Kubernetes, you can learn it on different levels. So you can learn it like an sysadmin or an administrator, and then you kind of learn how to install and how it works, let's say lower spectrum of getting deep into Kubernetes and getting to know how it works. How do you set up the storage? How do you hook up the storage to Kubernetes and so on and so forth? Then obviously you have your developer. And I think to your point, Christian, that should the developer have to know every ins and outs about the storage system? I don't think so. That may not be the best usage of that person's time.
It's an equally bad idea to tell me to develop something that it is to tell someone who's a developer to manage my infrastructure.
Yeah. So
it's different skill sets. It's different skill sets, at different languages, at different tribal things. There's a bunch of differences there, and it's not the same.
You've got a bit of Python in there, I'm sure, Christian. You know, you can pull that together.
It's in there somewhere. We know it.
Yeah. But these are different disciplines.
Definitely.
Right? But should be.
Yeah, they should be. And I think also that one thing that we have as a goal when we speak to our customers is we want the in-house environment to be as slick and easy to work with as any cloud. So we don't want
that's the other side of it.
Yeah, we don't want any of our customers to have to go to cloud in order to get away from their own IT.
Exactly. But from the developer perspective, Kubernetes is Kubernetes. Regardless of if it's on-premises or in AWS or in Google Cloud or in Azure, it's basically an API they can connect to and do stuff with.
Yes.
And it's the same experience from the developer side of things with regards to talking to that API, regardless of where it's run. But on the back end of that, there are huge differences between running Azure and on-premises.
No, but I've heard that you have something called serverless these days, and they don't use any servers. So
yeah, exactly.
That's fine.
So if you use serverless to deploy your containers on Kubernetes...
Okay, whoa, hold on a second. Yeah, I'm going to say, okay, so we talked about microservices, so we understand that microservices are taking an application and breaking it into your 37 or 40 individual chunks. So what's the difference between that and serverless? Because serverless has been a thing with regard to the way that the cloud worked relatively recently, maybe the last 4 or 5 years. So how is that different from microservices or even containers?
Yeah, so I would say microservices is definitely the design pattern that you use when you use serverless. So for sure, you can't really do it another way. So, and then serverless is just another abstraction layer for the developers. So instead of going to Kubernetes as the API, they go straight to the function as the API. So in AWS, we have something called the Lambda, for example, a Lambda function. And then you use that, and that is one of the 40 chunks that we spoke about. So that could be one of those chunks. So basically, you have just moved up a step in the abstraction layer. So instead of speaking to lower level Kubernetes, you speak to higher level serverless. So there is actually, you can get the serverless functionality in Kubernetes if you want to go the serverless route, which is not a bad one. You can do that in-house as well and have a serverless API installed in your Kubernetes, and then it will use Kubernetes underlying capabilities in order to provide you with auto-scaling and stuff that you want to have happen anyway.
It sounds very similar. Is it one of those situations where there's there are certain workloads that work much better with serverless because of their performance than they would with containers, but maybe in reality you could probably use both to do the same thing? Is it a bit like that?
I think it's more of a developer, cluttering thing. Yeah. So remove all of the clutter and I just want to do this function. So I'm not saying that it's good or bad. It's just one step further away from, let's say, programming in assembly on the hardware. So we're just moving up the hierarchy and saying, okay, we don't even want to care about the Kubernetes API part of it. We just want one layer on top. And in the end, you have, we have stuff like where you can just, in the web, you can just point and click stuff together. Obviously not as complex, but you can do stuff like for a normal user, they can get their web page running by just pointing, clicking and so on. So, and the last step of the spectra would be something that is very, very finished, and you kind of just choose a couple of variables and you have something up and running. Obviously, that doesn't suit companies that has to build their own, business logic and stuff like that. But so we're just moving up the abstraction layers.
What about? Okay, good question. Good answer, I should say. What about the nature of the fact that everything we've been talking about here, to a certain extent, with the possible exception of serverless, because that's more developed for a specific selection of clouds, is open source. So all of this stuff is open source based. So is that a good thing or a bad thing in this situation? Thoughts?
Yeah. So
are you a fan?
One could even, I'm definitely a fan. One could even argue that this would never have happened without the open source movement. So because in the old days, and I'm not even old enough to remember this, but then you couldn't really build custom software. You had to buy a license from companies like HP or whatever to use their stuff in order to build more stuff and so on. So when the open source revolution happened, well, suddenly you can do whatever you want, and we have had an explosion of stuff happening, the last 25 years or so, and I don't think that would have been possible without open source.
Open source in this kind of environment is really something that spurs innovation, right? Because you can spin up something new and give it to the world and see what happens with it, and people run with it and they suggest things, and things happen in a very dynamic way. The other part of that is there's a lot of it. I mean, if you go in to look at the CNCF, the Cloud Native Computing Foundation website, I mean, there's right now 183 projects, right? I haven't looked at the numbers for this, but how many of those are load balancers that do automatic HTTPS certificates from Let's Encrypt? It's a few. So how do you navigate that? If you're starting with this, how do you navigate finding which pieces fit you, and how do you pick? I mean, there are so many choices. It's not a turnkey solution at all, right? It's not something you let's have Kubernetes and everything and just plug it in, and now we have that now. Good, right? It's not like that.
No, you want a load balancer? Well, here's 50. You choose, and it's like, well, which one do they recommend? They don't recommend. It's open source. It's not like going to, I don't know. Well, we're used to Apple and Microsoft just providing and dictating. So having the choice is, well.
So this is something that is a little bit terrifying to people that are new to open source, because suddenly everything is exposed. I mean, if you would have the same exposure of any other application, let's say from Microsoft or Apple, they use a lot of projects in the back end. There's a lot of teams involved. There's a lot of stuff involved. So they probably have a lot of choices as well, or they do have a lot of choices as well. But they're not exposed. So if you're not used to open source, you're not used to seeing all of this clutter. You can't see it, because you get one shiny thing and this is your thing and you use it and it's all good until it's not good anymore, and then you complain and hopefully someone fixes it.
No, they just ignore you. That's just the way they went.
Yes. So, but to the question about how do you choose, that is a very good question. And then we have companies like Red Hat, IBM Red Hat, SUSE and Mirantis that are, or even VMware these days, I should say, that provides distributions of Kubernetes. Like Linux, Kubernetes is not a thing that you can run on its own. So Kubernetes is just one part. For example, there is no networking in Kubernetes. You have to plug in networking. There is no storage. There's not even a container runtime in Kubernetes. All of those things has to be plugged in. So Kubernetes only does its one thing. It's like Linux. When you speak to Linux person like myself, and I know that the other guy is a Linux person as well, if they say Linux, they mean the kernel. But you can't use only the kernel. You have to have the kernel and user tools and everything else. Otherwise, it's not usable. And that is what the Kubernetes distributions are about. So they have made an opinionated choice on all of these bits and pieces and said, here you are. This is our version of what a Kubernetes distribution should look like.
Wow, with or without sandals? Do sandals,
exactly.
Socks, does that sort of stuff? Is this the sort of
optional
stuff that keeps you entertained in the evening? You lie in bed thinking, wow, well, which version of the load balancer should I use today? Oh, look, a new one. That sort of stuff. Is that it?
I mean, shiny things are always there, and you have to have some level of restraint when how much time do you spend on shiny things. And you can't spend too much time on the shiny things, because then you will just be, looking at those things all of the time.
Mm. So, yeah, and in this kind of Kubernetes and container world, you'll spend all your times in YAML files instead.
Exactly. If you don't hate YAML, you will.
You will
after a while.
Yeah.
So
maybe we should just describe what YAML is for those who may not know.
Yeah, so obviously YAML is just another markup language, YAML.
Yeah. Mm.
And it's indent-based, so you have to have indentation correct, otherwise nothing works. Mm. And it's fine when it's very, very readable, actually.
Yes, it is.
So when you have a small YAML file, it's fine.
Yeah.
If you have a YAML file that is 4,000 lines long, it's not fine anymore. Yeah. It's like, Dorothy, you're not in Kansas. This is something has gone wrong here.
Yeah.
So.
If you look at an XML file, you've got loads of sort of pointy brackets, slashes, pointy bracket, slashes, pointy bracket. YAMLs are like that, but they just use commas or something else on those. They use different characters instead to minimize the amount of space they take up for those
It's things. Very, very readable compared to XML, for example. XML is not meant to be read by humans.
No.
YAML is meant to be read by humans.
Yeah.
So.
Yeah. Yeah, good.
But it's fun to work with if you don't have all that experience with it. I mean, It's I run a bunch of containers in my home network. Do stuff.
Why am I not surprised, Christian?
I'm not running Kubernetes. I'm just running containers in VMs.
Look at Jonas's face. Look at that face.
Yeah, I'm probably gonna get a telling off.
Yes,
afterwards.
I think that's definitely going to be the case.
I might have to let him do some things in my home lab, but I have this, since I'm not using a Kubernetes distribution. I've been kind of playing around with doing different things on my own. I don't need auto scaling and all of those things that Kubernetes provide, but so I've set up Caddy to do some front end load balancing, and then wait, traffic sounds good. Let's try that, and then I don't use it for a month, and I go back, and I don't even remember where my front end was and which DNS points to what and how that service was really meant to work at all anymore. And now it doesn't work anymore, and I don't know where to start troubleshooting. So I've had a lot of fun with containers. I'm getting the hang of it doing that now. So I might just now have to go on to do Kubernetes instead, just to have the automation part. But I needed to kind of understand the container part of it first.
Let's use that because the key. How difficult is it to deploy and utilize? If you've developed your application for containers, how easy is it to deploy and utilize Kubernetes to be able to then manage that container, just like Christian wants to?
So actually, the maintenance or keeping the lights on is done by Kubernetes. So that's where Kubernetes shines. No pun intended. So Kubernetes automatically restarts your container if it fails. We actually speak about pods as the smallest part that we talk about in Kubernetes, but let's not go into that detail. So it will automatically restart it if it fails. If your underlying node breaks or gets stolen or whatever, it will relocate the pod to another node in the Kubernetes cluster, assuming that there is another node available, and so on. So actually, keeping stuff running in Kubernetes is very simple. Keeping order in all of the stuff that you have to do in order to deploy and do all of the things that you want to do with Kubernetes really dictates some sort of system. And obviously, when we work with companies that have a development team and so on and so forth, they use pipelines. So in their pipeline, they will deploy to Kubernetes as like the last step in the pipeline. That's very common. Or maybe if you do that to like dev and test and then to production, you have an intermediate step where you say, okay, someone has to improve this, or we're promoting this, image 42, of course, to be the best image that we would want to deploy to prod and so on. But I really think you should start to look into as code and doing stuff with something like Ansible, for example, to not only for Kubernetes but for all of your stuff, basically. So otherwise you'll have nightmares about it, and you can't do it manually. So I think it's good because I've been using automation and Ansible for a very, very long time. Coming from the Unix side, we just scripted things in the beginning, but since 94, I think, when CF Engine came out, which was a configuration engine for like automation like Ansible, but its predecessor. I've been working with automation, and it greatly simplifies things.
Yeah.
But
as long as you have that structure, you've got to have that structure in the first place to be able to simplify it. You need a defined selection of repeatable tasks.
Yes.
If you're a little bit more haphazard in the way that you build stuff, very difficult. But if you're structured, Jonas, which I'm sure you are.
I think you should be structured enough, and then obviously you need to go and look at those shiny things ever so often, because you have to look at new things, I think, but stay focused. So I actually have allocated time where I can look at stuff, and then I can't do it anymore. So you have to be disciplined here.
Yeah.
Otherwise, you'll only be looking at new stuff and never do get anything done. So.
Yeah, that's the thing. It's a huge rabbit hole, right? You mentioned Dorothy wasn't in Kansas anymore, so let's go down the rabbit hole as well. Because if you do that, there's all of these things, and you'll never kind of figure out which one you should use because there's always something new and shining around the corner. Yeah. So you start playing with that. And that's what happened in my home lab, right?
Is this like IT TikTok? You just spend your time staring at videos. Is that the way it works?
Yeah.
I think so, yes.
Yeah.
Bizarre. So I suppose the one thing I would say, to finish this off, is, Jonas, why would you recommend containerization and Kubernetes to people, or what businesses would you recommend this product to? Just from your own experience.
I mean, I think if you have a development department or if you're developing in-house code, then not looking at Kubernetes, I think, is a mistake. And even if it's just to inform yourself about, what is this thing and why is everybody speaking about it? And for non-technical people, I think there's two very distinct, opportunities here. So the single targeting is very, very important because it really makes life easier when you need to, get people, explain what the target is and so on. So it's both from a technical perspective but also from a business perspective and, requiring an HR getting people in. And it's hugely beneficial and very unique, I think, in our industry that it's this simple to describe what the target is.
And certainly from my point of view, I think it's one of those things where if it's quite easy to protect by comparison to some of the monolithic operating systems we have out there. I think it's probably inherently more secure because there's less going on. And so I think we will talk about security in another podcast. But I think the fact that it's open source, it's well understood. There's a lot of people out there who understand how to secure it and how to tie it down. I think it's probably a more secure environment to be able to present applications from as well. Which is in this foundation
there's a foundation that owns it. All of the big players are in there, contributing to this thing, but they don't have the ability to say, okay, now I'm going to go rogue and just raise the prices and so on. So I think this is a really, really good thing for software.
Nobody goes rogue, do they, Christian?
No, never happens.
Okay, anything else to add, Christian? Yeah, go on, Jonas. Go on.
No, I was going to say that have you been in the industry for more than 2 years? If you haven't, had the occasional raising of prices or, redoing the licensing agreements and so on, so then
it's a biannual experience.
You.
Yeah, exactly.
Yeah, congratulate you, but it's not going to stick. So.
Nature of the game. Christian, anything to add before we finish?
No, I think that was good. I'm looking forward to this. I mean, we're at the point now where I think there's a kind of an inflection point where software houses that develop software that businesses use will also start providing those applications as containers to the end customers, right? To the business customers. Until now, we've been, okay, here's an installed package, be it on Linux or Windows or whatever. We stood up a VM, we put in the applications, either the vendor did that themselves, or we did as admins. But that was kind of a way of distributing software that might be waning off a bit, because if the software vendors for on-premises application can provide you with a microserviced container environment described in a YAML file that you plug into your API and your application is up and running, that makes a lot of sense, right? And it makes it easier to maintain that as well over time. So I think we're shifting towards that. It's going to be a slow run. I mean, it takes time. But I think most businesses should be looking into how they can provide Kubernetes as a service inside of their data centers, because at some point they're going to have to.
And I think that's the key thing, is the fact that it's not so much there's the developers, there's the infrastructure, now there's this line in the middle that is the Kubernetes experience that you need. So I think, having all three of those things is going to be an advantage moving forward.
Yeah, and the single target obviously extends to the software producers as well. So
yeah, absolutely.
Like Christian said.
Good stuff. Great stuff, guys. Thank you very much for that. Interesting chat. Thanks very much for joining us, Jonas. Much appreciated.